Hello everyone and welcome to another Add Maths tutorial video. Now I'll be discussing SPM 2019 paper 1 question number 25 from Form 5 chapter 8 probability distributions short question. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. Diagram 11 shows the normal distribution graph of the time for a school bus to arrive at a school. So this is the bell curve. So from here, the question part A, they ask us to find the standard deviation, and the question part B, it is given that the mean time for the bus to arrive at the school is 7:15 a.m. Students are considered late if they arrived after 7:20 a.m. Lee take that bus to the school. Calculate the probability that Lee will be late. Give your answer correct to 3 significant figures. Okay, so this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solutions. So without further delay, let us start to solve the question. Let us solve the question part A, where they ask us to find the standard deviation. Okay, this probability distribution question is literally new, guys. Okay, not for the students but also for the tutors, and to be honest, this is one of the toughest question that I've solved in this SPM 2019 paper 1. Okay, so let us solve this question together. So as you look in this diagram 11, you can see that this portion has 25% and this portion also has 25%. Okay, so this bell curve, as you can see, is perfectly symmetry. So what you're going to do is, so assuming that this two portion is symmetry, so it will be 25%. Okay, since you have 2 minutes and 2 minutes which you have equal difference. Okay, and this region you also have 25%. Okay, by the way, this percentage means probability, guys, in this case. Okay, the area under the graph indicates the probability. Okay, and then if you take a look in this diagram, you have no idea the mean. Okay, the mean is not provided, so from here let us label it ourselves. Okay, this is our mean, mu, and then the x value is not given directly, so we need to find from the diagram over here. So in this case, let us set our own x value. In this case, we can set this as x naught. Okay, so from here, the area under the graph for this specific region is 25. We can literally relate this region with the Z table. Okay, so from here, to get the standard deviation, what you're going to do is we're going to go in the reverse direction. Okay, so please follow up with me, guys. So from here, probability Z more than x naught minus with mu divide with sigma is equals to 0.25. Okay, this 0.25 is this particular region, guys. Okay, which I've shaded for you. Okay, let me underline the fraction over here. Okay, in the question, they didn't give us the x naught and the mu, but they give us the difference between the x naught and the mu, which is 2 minutes. Okay, so we can use these 2 minutes and include in the working over here. So from here, probability in a bracket z more than, okay, so your x naught minus mu now will become 2. Okay, and then you divide with the standard deviation sigma. Okay, and you equal to 0.25. So for the next step, what you're going to do is we're going to take a look in the Z table, and we're going to find what is the relevant value of Z when your probability is equal to 0.25. Okay, so let us take a look at the Z table now. Okay, so this is your Z table. So let us take a look at the value of 0.25. So okay, if you take a look over here, so this is the closest value that you can possibly get. Okay, so 0.2514. Okay, where it is at 0.67, okay, where your z is 0.67, but then you have the 1 4 over here, so you need to eliminate this 1 4. Okay, so what you can do is you can try to minus with 1 3. Unfortunately, there is no 1 4, guys. If there is 1 4, of course we can minus with 1 4 over here. So the nearest value that we can use is 1 3. So from here, from the z table, you should get your relevant z value is equals to 0.67 and 4. 0.67 and 4. So we're going to use this value into the calculation. So back to our working now. So from the z table, your z is equals to 0.674. Okay, remember guys, the formula to find the z, where equals to x minus mu over sigma. So we're going to compare this 0.674 and then we're going to equate with the 2 over sigma over here. So why we are doing that? So that we can find our standard deviation, okay, for the question part A. So from here, 0.674 will be equals to 2 over sigma. So from here, your sigma, or also known as the standard deviation, is equals to 2 divided with 0.674. So from here, you should get your standard deviation sigma is equals to, okay, let me press my calculator, 0.674. So from here, you should get your answer 2.967. 2.967. So this is your standard deviation. Okay, let me underline the solution for the question part A. Okay, so let me proceed to the question part B now. For the question part B, we are still using diagram 11 as our reference to solve the question. Okay, so based on the information given in the question part B, they mentioned that the mean is 7:15 a.m. So let me write over here 7:15 a.m. so that you can know this is your mean. And then they also mentioned that the students is considered late if they come 5 minutes after the mean time, which in this case is 7:15 a.m. So 5 minutes after 7:15 a.m. is 7:20. So 5 minutes should be around here. Okay, should be over here. So let me label it. Okay, over here. And for this x-axis, we label it as XL. Okay, why letter L? Since in the question, Lee is the students that involved. Okay, so that's why I'm using as XL over here. And let me write here 7:20 a.m. and the difference between the two time is 5 minutes. Okay, let me label that as well. Okay, from the mean to the XL, it will be 5 minutes. Okay, so please follow up with me on how I'm solving this question. So similar to the working which I've done in the question part A. So from here, probability Z. Okay, we are interested in this particular region, guys. So from here, your Z will be more than XL minus with mu, then you divide with sigma. Okay, we don't know the exact value of XL. Okay, even the mean also they give us in terms of time, but then we know the difference between the XL and mu, which in this case is 5 minutes. Okay, so from here what we can do is we can include this 5 minutes into our working here, and the standard deviation we have already find in the question part A, which is 2.967. okay, we can include that in our calculation. So from here, probability Z more than 5, okay, and then you divide with 2.967. Okay, you calculate this. So from here you should get your probability z more than, okay, let me calculate this, guys. So from here you can write your z value in 3 decimal place. Your z will be more than 1.685, close bracket. Okay, for the next step, what we're going to do is this z value we're going to find in the z table, and then we're going to find the respective probability. Okay, so let me open up the z table now. Okay, so this is the z table. So now we are required to find the probability value for 1.685. Okay, this is 1.6, okay, and this is 8. Okay, when you intersect this both, so from here you should get 0.0465. Okay, let me circle this as well. Okay, but that is not the end, guys, since they mentioned 1.6, 8 and 5. Okay, this is number 5. Okay, when you intersect over here, okay, so this is the 5 that you need to minus with the last digit over here. So from here 0.0465, okay, and then you minus with the last digit over here. So from here you should get 0.0460. okay, that is the required probability, guys. Okay, so back to our question. So from the z table, let me write this properly. Z table. So from here you should get your probability is equal to 0.0460. so this is your final answer. Okay, let me underline the solution. Alright, that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Thank you everyone for your support, and I'll see you in the next video.